In this video, we will do diagrams for a diverging lens. And so, well, let's draw it. So let's draw a diverging lens. Here's let me do a central axis first. So here's the axis of symmetry. And then here's the lens, which is symmetric. So, symmetric right like this about its vertical axis. So there we go. Here's your diverging lens. Just remember that what happens here is you have if you have a diverging lens, then the rays of light as they come in, they will diverge outwards. And so you have a ray of light that comes in here, goes out like that. You have a ray of light that comes in here, it goes out like that. Maybe I'll do one more here and one more here. And in this case, you do not have an actual focal point. You do not have a real physical focal point. But if you do make these extensions, if you do draw these extensions here, you will find out that all of these point to the same point, and that is the focal point, the virtual focal point, but this is the focal point that we would use. All right, so now what we need is, what we need is a focal point somewhere. So here's your focal point, and then we need an object, and let's say here's your object. Now I want to draw this in a way that, let's see, that is not very convoluted if I can help it. Let's make this thing bigger than in that case. Draw it like this. Okay, so here's the object. And what I need is 2 rays of light that will do the trick for me. Out of the billions available, one of them is going to reflect off of the tip of the arrow in such a way that it will go in a direction that is parallel to the central axis. But let me use a different color for light. The light reflects, goes in the direction that is parallel to the central axis, gets to the lens, and then it diverges. It diverges out as if it was coming from that focal point. So it goes like that. All right, so I'm going to draw this ray of light that goes out like this. That'll do. And here's the direction. So what I can do is I can draw this little extension here. I need to transfer that focal point to the other side. So I have focal point on both sides. I have to make sure that they're equidistant to the lens itself. So somewhere here I have the other focal point, and one ray of light that I have here won't do the trick. I don't know where the image will be, but I could draw another ray of light that goes from the tip of this arrow. So a ray of light comes in, reflects off the tip of the arrow, and then it goes in a direction. It goes as if it was coming to this focal point. It won't manage to get there because of the shape of the lens, but it goes as if it was going to that focal point. So it stops somewhere here, and then it changes its direction. And how does it go? Well, think about it. Maybe pause the video and then come back. It goes like this, to go in a direction that is parallel to the central axis. And it's fairly easy to see why that's the case. Retrace this backwards. And if, suppose you have a ray of light that goes to the left instead, when it gets to the lens, it diverges out as if it was coming from this focal point. All right, so now I have these 2 rays of light. One goes like that, the other one goes like this. They don't cross, so obviously they won't make an image, but their extensions will cross. So here's one extension, this one, right? So here's an extension that goes like that. And here's the extension of the other one. And the way I should think of it, is here's, my eye. This is where my eye is sitting, right here, right? And so that ray of light will come to the eye. This ray of light will come to the eye. And my brain will interpret this information as if so the information that comes along this path, my brain will interpret this as if it was coming from this direction here. And my brain will interpret the information that comes along this path as if it was coming from here. And so the brain will think that the object is here. And so the image is going to land right at this location. Here's where you would have the arrow. So this diverging lens will make things look smaller. And in case you're wondering, well, that's just 2 rays of light. That couldn't possibly give me an image. Well, what you would do is you would draw more of these rays of light. And let's say you have another one that goes like this. Well, this one's going to refract and go in such a direction that it still ends up in your eye. Should have drawn this eye a little bigger. You'll have another ray of light that goes like this, refracts, and it goes in this direction towards your eye, and so on. You know, and of course you have millions of rays of light here between these 4 that I drew, and all of them bring you information about the tip of the arrow, and you think that the tip of the arrow is right here. Turns out that this is the only way you can draw a ray diagram for the diverging lens, but I'll do a variation of this. So that suppose that you have your lens right here, and then the object is here. I want to make sure that this is actually, that I can actually draw this stuff. So if it goes, okay, so suppose that the object is here, but now it's within the focal length, so that I have f, you know, at this location. And the question is, where will I see the image? Well, so let's transfer the focal point to the other side first. I have to make sure it's equidistant. So somewhere here was where I would have the second focal point, right? Somewhere here I have f. And now let's draw 2 rays of light that will do the trick. So one of them, out of the billions available, one of them will reflect off the tip of the arrow and go in a direction that is parallel to the central axis. It hits the lens and then refracts in such a direction that it goes away. It diverges out as if it was coming from that focal point. So I'm going to draw a line here that goes like this, right? And so here's 1 ray of light. The second ray of light is going to reflect off of the tip of the arrow and go towards the lens as if it was going to get to the second focal point. I have to use both of the focal points to make this thing work. Now it's not going to get to that focal point because of the lens, right? So it's going to simply get to the lens and then refract and go in a direction that is parallel to the central axis. And so this is how it would go. And it's easy to see that this would have to be the direction of this ray of light here, because retrace it backwards. So if ray of light was instead going to the left, it hit this lens and it would go out like that, as if it was coming from this focal point. All right, so now that I have these 2 rays of light, well, your eye again would sit here and it would be receiving these rays of light. So here's 1, and you know, your brain interprets the information as coming from this direction. So just run the extension. And likewise, your brain interprets this information as if it was coming from that direction. So run extension. Wherever it crosses is where your brain would think that the object is. And so this is where you would have the image. So this is the image, and it would be a virtual image because it's not formed by actual rays of light. Likewise, this would be a virtual image. Virtual image because it's not formed by actual rays of light. And that does it for the diverging lens. There's not much more here than what's been drawn. Okay, so that's a diverging lens.